So now we will look at another example of AB. So first, so this is the direction AB. So according to our procedure, here we will take the origin as A and the coordinate system as DAB. So the point in the direction of AB is B. First, we will find the coordinates of B with respect to the new coordinate system. So the coordinates are A00. So the coordinates here are A00. We will divide it by the corresponding lattice parameters. So that is A divided by A, 0 by B and 0 by C. So you will get 1, 0, 0. These are the smallest integers, so we need not reduce it further. So the Miller indices are 1, 0, 0. These are enclosed in square bracket. So Miller indices for this direction AB is 1, 0, 0. And this 0 means the direction is perpendicular to the corresponding axis. So you can see that in this direction 0, it corresponds to y axis. So AB is perpendicular to y axis and this 0 corresponds to z axis. So AB is perpendicular to z axis also. Now we will find the Miller indices for the direction OB. The first step is to select origin in the direction. We select the coordinate system OXY with this origin OXYZ. Now the code we will find the coordinates of a point B in this point in this direction, that is B. So we will find the coordinates here as A, B and 0. And then we will divide it by the smallest integer. So will be 110. Miller indices we get as these are the smallest integer, we need not reduce it further, and so we will enclose in square bracket, so thus we get the Miller indices 110. As usual, the 0 indicates that the direction is perpendicular to the corresponding axis. See here in this direction, OB is perpendicular to the Z axis. Okay, this corresponds to Z axis. We look another example. So here the direction is OC. We will try to generate Miller indices for this particular direction. Here the origin is O and the coordinate system is we will select as OXYZ. So this origin is in the direction, so we need not take another origin. So the coordinate system still remains there. Now we will select another point, that is C in the direction, and we will find the coordinates of this point. So the coordinates here are, it is A, B, C. So we will divide it by the corresponding lattice parameters. You will get 1, 1, 1. These are the smallest integers. And then we will enclose in square brackets, that is 1, 1, 1. So these are the Miller indices for the direction OC. Now let us discuss what do you mean by family of direction. Till now, I have discussed about how to generate Miller indices for a particular direction. We have seen that all the directions that are parallel to each other has got the same Miller indices. But let's take the example of a cubic lattice. Cubic lattice. Its lattice parameters are A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. So this basically means that if you take any axis like in this direction, that is x, y and so let it be z and this be x. By symmetry, you can this cube will be symmetrical in all these axes, along all these axes. So let us take the direction 0, 0, 1. This depicts the z-axis, and 1 shows the x-axis, and 1, 0, 0. So 1, 0, 0 shows the x-axis, and this shows the y-axis 0, 1, 0. Okay. They all are equivalent by symmetry because A is equal to B is equal to C. These are symmetrical with respect to X, Y, Z. So even if you rotate it along this axis by 90-degree direction, so that means if you rotate here by 90-degree, so Z axis with X axis with no change in the crystal system. So that is why we say that these are all equivalent direction. Similarly, additional directions like 1, 0, 0. The one bar represents the negative direction. See, 1 is in the positive x-axis, 1 bar is the negative x-axis. So 0, 1 bar 0 and 0, 0, 1 bar are all the family of direction. All are equivalent by symmetry. So we will depict it by using this symbol 1, 0, 0, showing the family of direction. All these are equivalent for a cubic crystal system, for a cubic lattice. So now let us look at another example. So here the directions how I have chosen is 1, 0, 1, 1, 1, 0, and 0, 1, 1. If you pay attention, all these directions are equivalent by symmetry. That means if you rotate this crystal by 90-degree in the x-axis, y-axis, and z-axis, all these directions will be equivalent. So these are all equivalent. You can also write -1, -1. So 1 bar 1 bar 0, this is equivalent to -1 -1 0. So all these are equivalent. So these are all equivalent. These directions are equivalent, and this comes under one family, that is 1 1 0. Similarly, if you look for this direction, that is 1 1 -1 and 1 1 1 and -1 1 -1, these directions are equivalent for a cubic crystal. Cubic crystal. They're all equivalent directions. So, the, so these directions 1 1 1 minus 1 1 1 1 minus 1 1 1 1 minus 1, these all come under the family of directions 1 1 1. Next, you have the Miller indices for a family of symmetry related planes. Sorry. Here we are making a comparison between cubic lattice and tetragonal lattice. So for a cubic lattice, we have seen several family of direction. You can see that these, for this family, that means this comes under 1 0 0 0 0 1 0 1 0, all come under one family, that is 1 0 0. Okay? Because the lattice parameters all the ABC are equivalent, and this angle between them are 90-degree. Now, if you take a tetragonal lattice, in a tetragonal lattice, you can see that uh, this x-axis and y-axis, both lattice parameters are equal, but in the z-axis, this C is different. That means A is equal to A is not equal to C. So if you rotate this z-axis here in the x direction, then the crystal will change. Similarly, if you rotate this z-axis, if you rotate this crystal 90-degree in the y direction, then the crystal will change. You can see that this direction does not come under the family of these two directions. Okay, so here 1 0 0 and 0 1 0 0 1 comes under different families. Okay, under 1 0 0 you can have the group of directions like 0 1 0. Okay, these come under the same family. and this family of direction is different. You can see that this direction belongs to a different family, but these two directions both are under the same family. So this is the difference.